Before we begin with the next section, we need to understand the difference about direct current and alternative current, DC if not AC. So the definition is quite simple. In direct current, an electrical current whose magnitude is either constant or varying, but the direction of flow of current remains the same. What they mean is when we switch on the current, so we know that in a battery or a cell, the electrons will start moving from one end, it goes to the other end, right? So the conventional current direction is the opposite. So it will be something like this. So if we happen to draw the graph, right, of our DC current, graph of what? Current voltage, if not current time, if not voltage time graph. That is, if I switch on a circuit which has a DC source, the current and the voltage will increase gradually. I mean, it's actually just take a very, very small amount of time, and then it will remain constant. And say the battery is getting weaker, so it will decrease slowly. Of course, not in this manner, but I'm just drawing for the sake of discussion. And maybe in time drop altogether. So the thing is, the electrons will never travel back. Is as simple as that, right? That such movement of charges is your DC current. Okay. Source of your DC is your voltaic cell, dry cell, solar cell, and DC generator. So we'll be looking into this. Yeah, other things you guys have a basic idea, right? So one more fact about DC current is that the frequency remains zero. That is the value of the voltage or the current, right? The value, the reading of this voltmeter ammeter will not fluctuate between any values. So you will understand this point better and all of this better once you have a look at your AC current. So when we have an AC current, right, let me read the definition again first. An electric current whose magnitude changes with time and direction reverses periodically is called an AC current. What does it mean? It means that if I happen to plot a current, if not voltage, against time, so this is or, by the way, it's not divided by, it's supposed to be or voltage. Okay, here too, it is current or voltage. Okay, yeah. So if I happen to divide in this manner, I will not divide again. If I happen to plot, basically, so the current and the voltage might fluctuate like this. So what is happening? Can you guys guess? See, I'll take in terms of voltage. The voltage is gradually increasing and dropping to zero, and having a negative voltage dropping to zero, positive voltage dropping to zero, negative voltage dropping to zero, right? Negative voltage if not current. This is positive values. This is negative, positive, negative. See, this is the ammeter and the voltmeter reading. What does it mean? For some point of time, the circuit will look like this, right? And the next moment, it will look like this. So it will be switching between these two extremes. Okay, so basically it will be switching between these two phases. So it's like you're replacing this set of batteries over here in place of this symbol is there, right? This symbol represents AC source. Okay, whenever you see this symbol, it means AC source. Similar to what you have DC, that is your AC source. Okay, so now moving on. So basically we are switching around this two values, or not values, actually scenarios. So for a fraction of a second you put this, and next fraction of a second you do this. Okay, if you do that, what you will end up seeing is kind of a DC AC source. So to be honest, it will end up looking like this, a square shaped structure, not this sine wave. Anyways, let us not go to that. Point is, it will be switching between two extreme values. So this is the maximum and this is the maximum at the other extreme. So basically, if you look in terms of electrons will go forward, and in the next fraction of a second, it'll come back. Okay, so let me show that. Electrons will go forward. In the next fraction of a second, it will come back. Go forward, come back. Okay, when you switch on actually. So this is what happens. Right? Makes sense? This is your alternative current. So this is your direct current. So here the frequency 0 means what? Basically the electrons won't go and come back. Right? So there's no frequency. Frequency means what? How often something happens. Right? Here you have the current going forward, like having a positive value, the negative, positive, negative. So there is a switch between two values. But in AC, there's no switch. Sorry, in DC, there's no switch between two values. Does it make sense? Right? The electrons will flow in one direction. The rate at which it flows, it can vary. Now, this is this section from, say, this is O, A, B. AB, there is a constant voltage, if not current, whatever you guys want to read it as. Then BC, there is reducing voltage or current, again, whatever you guys want to read it as. And CD, again, faster rate at which it is dropping. So that is the number of electrons that is moving from one end to another end is reducing in time. So that's what BC and CD means. Reduction. But there is no back and forth movement of electron. Okay, so in AC, this happens. It's back and forth movement of electrons. So that we can talk in terms of frequency. Okay, so that we can talk in terms of frequency. So let me just change this so that there's no confusion. Here in AC, we can talk in terms of frequency. So in India, we are provided with 60 hertz. I think 60 hertz. Yeah, I hope so. I keep forgetting this. So just a second. So as told, I was wrong. It is 50 hertz. Right? Good that I checked. So this is 50 hertz. Okay. So that is the value of the current and the voltage runs 50 times between these two extreme values. Okay. 50 times in 1 second. That's what frequency means, right? So in 1 second, it's happening 50 times. So that's a lot. Is it not? Okay. So you guys have to pause and copy all of this.